This is absolutely crazy. I just created the firmware of my custom ESP32 Power over Ethernet sensor without writing a single line of code within minutes. And no, I didn't use ChatGPT. 5 months ago, 5 months already, I got a comment and it was the first time that I learned about a thing called ESPHome. ESPHome lets you compile custom firmware based on a config file. So you just tell it, I have this sensor connected to this pin, I have this sensor connected to this pin, and that's it basically. I will put in all of the sensors and then we see if everything works as expected. I think everything is mounted except Sauron's eye, because it's quite expensive. Let's see if it burns. Okay, it looks like everything is still fine. We should have 12 volts on these pins. Yes, awesome. Usually it takes days or maybe even weeks to create a firmware that actually works and that utilizes all of the sensors on my board. And now we can do this in a matter of minutes. Let me show you how it works. So this right here is the basic configuration that was needed in order to get the network up and running. It works great, the LEDs are blinking, everything is great and it's connected. And the great thing about this is we can now just recompile the firmware and upload it directly over the network. So it's connected to my local network and all I have to do is run this command. It checks my config file, it recompiles everything, and then it just autos it to the board. That's it. You can use Wi-Fi if you want, or you use Ethernet like I do. In the beginning I thought maybe I'm lucky and some of my sensors are actually supported by this ESPHome. But boy was I wrong. Almost all of them are supported. It's completely crazy. Let me show you. If you take a look at my schematic. So let's start with the first sensor. For example, very easy brightness sensor. We have an LDR on board to measure the brightness in the room. That's what it does. It is connected to GPI 39. So what we have to do is, in addition to all of this, we add these few lines. We add a sensor. It's an analog digital converter sensor. We need to define the pin. Of course, this is connected to pin GPIO 39. I can give it a name. So for example, living room, LDR, and an update interval. Well, in the future, I'm not sure if I will stick to 1 second, but for now, for testing, it's perfect. And I add a 12 dB attenuation in order to be able to measure higher voltages. And that's it. I save the config file, stop the script, and I run. And as you see, it checks it, it compiles it, it uploads it, and it was successful. Starting and boom, that's it. And it's already delivering values here. So these are live values sent over the network. Let's make it dark, the voltage increases. If I make it bright, the voltage decreases. Crazy, absolutely crazy. I'm blown away. Yeah, but let's continue. It gets even crazier. Let me show you. We have the DHT22. Now this one is measuring humidity and temperature. It's connected using GPIO 33. So let's just add this to our list of sensors. So we have a DHT, and by the way, I'm not making this up. The project has a great website, so you find DHT22. Yeah. You find some examples right here, how it looks, what kind of parameters you need for a certain sensor. Everything is perfectly documented. I'm so blown away. I'm not sure if you noticed, but this is crazy. I will keep an interval of 10 seconds. So all I have to do is save the config file, stop the script, and rerun the script. And it recompiles everything. It uploads the firmware to my board wirelessly, not wirelessly. Well, my MacBook is wireless, so partly wirelessly. And now we also get the humidity in addition to the brightness. And I will actually increase this time right here. And you see I can do this very quickly. I just increase, save, and upload the new firmware. That's it. Boom. And now we get the temperature every 10 seconds. Amazing. Okay, let's continue. We have CO2 sensor. The CO2 sensor is using a serial connection. For the configuration, this thing right here, MHZ19, and what it needs is a UART. So I have to define a UART with a transmit pin 16 and receive pin 36 and a baud rate. Yeah, we can play around with the baud rate. I kept the standard 9600. And then we have to define, of course, an update interval. And that's it. Let's save it. Let's upload it. And as you can see, the CO2 sensor is warming up. All right, there you go. CO2 value. Well, it's time to open the window, I guess. It's just, I'm blown away. Crazy. I also have a speaker, and first I thought I would just turn the GPIO on. That's also one thing that you can do. You can define it as output and then you toggle it on and off. That's actually not enough. The speaker is a passive speaker. In order to hear something, you actually need to feed a frequency into the speaker. My idea with directly connecting the smoke alarm to my speaker doesn't work, because the smoke alarm, it doesn't output a frequency, it just outputs high or low, and so this right here doesn't work. I have to do it with my ESP, so I removed this diode and I'm now generating a signal with the ESP32. In order to make the buzzer work, we define an output platform LED C. This can be used for different things, and one of the applications is a buzzer, and it is connected to GPIO 14. Now we need to turn it on. For me, I would like to connect it to the smoke alarm. So as long as the smoke alarm is active, it should output a signal. Yeah, so this is my smoke alarm and it's connected to GPIO 34. So in this case, I created a binary sensor based on the GPIO platform, because it's basically a GPIO, it's just an input. And I call it living room fire sensor, GPIO 34. And now you can use different events, and one event is on press and one event is on release. The fire alarm doesn't really press anything, but what on press means is the transition from false to true. This means that the living room is probably on fire and we should output the signal. So if the living room is on fire, then we enable the buzzer. We set the frequency to, for example, 1000 Hertz. That's a very annoying frequency. And very important, on release, so if the fire alarm is deactivated, then I turn off the buzzer, because otherwise it just keeps buzzing. Okay, let's see if that works. And now it's time for a fire. So I will simulate the fire with my tweezers by connecting smoke to 12 volts, like this. And as you see, as long as I connect them, I get this annoying sound. And of course the thing also tells you that the living room is on fire, which is the whole point. So you have a local alarm even if the network is down for, I don't know, fire reasons, I guess. Or warn the network about it. Turn on even more alarms. And we have this movement sensor. And that thing is a little bit weird. I'm not a big fan of this movement sensor. It makes a lot of false positives. But yeah, it's also a binary sensor and based on GPIO. Call it living room motion sensor. It is connected to GPIO 35. And I will also enable the buzzer if it detects movement with a different frequency, so that we can differentiate between them. Oh, and there is a syntax error actually, and you can see that there is something wrong. Great. Okay, yeah, you get the point. I will turn it off because it's super annoying. So let's turn this thing off. Yeah, that's the last time. Okay. We also have this nice infrared receiver because I would like to control the house using one of these, for example. Yeah, I thought there is no way that this is supported by ESP Home, but actually they proved me wrong. There is a thing called remote receiver, and you just define the GPIO pin, dump all. You can also filter for specific remotes, or you just dump all. That's what I'm going to do. And then it looks like this. So as soon as I press the button right here, you get this remote codes, and it's amazing. I can point in this direction and it still works. So yeah, it's great. It can also transmit infrared signals because I added this circuit right here using 3 LEDs all over this PCB. I can send infrared signals all over the room. I could use this as relay, for example. So I press a button, it is sent to my sensor right here, and then it's been translated into a different protocol, and for example it turns on 5 different devices. This would be absolutely possible, and this is exactly why I built it, to remove the amount of remotes in the house, because it's super annoying to have all of these remotes. The transmitter looks like this. You define the GPIO. You need to set the duty cycle to 50% in case of infrared, and then it should work. Yeah, there is also this sound detector. So the idea is basically that I clap my hand and this clap is detected by the sensor and then does whatever it does. It consists of 2 things. I have this potentiometer. With the potentiometer I can select the threshold, and it's a digital potentiometer, so it's connected to the I2C bus, and it's sadly not supported by ESPHome. The output, on the other hand, is just a digital output, so this one works exactly like the movement sensor, for example, or the smoke detector. It's just a binary. So for now I can add this binary sensor here to my list of binary sensors, but the digital potentiometer doesn't work for now. However, there is support for external components, and that's exactly one thing that I'm going to handle in a different video, because this is a little bit more effort, I guess. So I will look into using external components to make use of my audio sensor. What else is on the board? I can use the integrated BLE and create a BLE proxy for my home assistant, because I have an ESP32 and it is equipped with Bluetooth. And the last thing that's missing is the IR matrix sensor. So we have this crazy sensor that I used in Sauron's eye. It's also not supported directly, so this is also a little bit more effort. But overall, I'm absolutely amazed by how easy it was to get my sensor board up and running. If this video was helpful, please like and subscribe to this channel if you want to see more stuff like this. Let me know if this is something that you could use in your home as well, because the next thing is I will 3D print the case and then I will mount this to the ceiling. Thank you so much for watching till the end. See you in the next video.